Hello, good day to Professor Maria IR, Dr. Dirma Hanafi, and followed by Inchaswamy bin Saiman as my panel for this project. So, first of all, my name is Tirmugan Son of Ravi, and today I'm going to present about my final year project. So, this is the first project, PSM1, and my supervisor's name is Dr. Jabbar Al Fatah. So, the title of my project is Solar Sun Tracking System for Water Heater. So for the introduction, I'm going to present about the renewable energy for this project. So first of all, the field of renewable energy is becoming huge nowadays as the demand and usage of the alternate electric energy increases day by day for both commercial sites and also industrial sites. So means the renewable energy is becoming demandful for nowadays compared to last time. And the major advantage the major advantage of renewable energy is that it will not extend easily or run out because the energy is keep on produced from the natural sources like sun and wind, which will always exist. So means the sun and wind is not going to finish, so it will be always extinct. Yes, exist. So the renewable energy is also referring as a clean energy as it is produced by a natural and safe to use, and there is no form of chemical reaction that may cause harm to the environment, unlike non-renewable energy, which is in contrast comes from finite sources that could get used up, source such as fossil fuels like coal and oil. So means the fossil fuels like coal and oil and gas is producing harmful substance with the chemical reactions to the environment, and it may affect the global climate change. So according to the agency, which is a international renewable energy agency, they say the renewable energy can and should provide 90% of the world's power by 2050. Means the renewable energy will become huge more than nowadays by 2050. So besides of that, there are numerous benefits of renewable energy exist and have impactful on the national economy environment, national security and public health. So for the example, it will increase the access to renewable energy from distance, coastal or island population without grid connections. So other than that, it can reduce air pollution and carbon emission from the energy generation, enhance national power grid, uh, resilience, security, and dependability, and as well as reduce the high cost of electrical bills. So that's basically why I'm choosing the renewable energy for this project. So for the problem statement, as a result of the steady rise in energy consumption is increasing day by day. So the demand for electricity and its efficiency has increased throughout the world. So compact renewable energy sources coupled to regular electricity transmission lines have grown popular in numerous countries. When the electricity demand increases tremendously day by day, the cost for set up the management to transfer the electricity will also increases and finally affect the consumers. So for the first problem statement, which is the poor electricity generation in rural areas leads to lack of electricity production to power up electrical appliances such as a water heater for the consumer, especially during the rainy seasons. So for rural areas in developing nations are frequently disadvantaged in terms of access to power because it is a rural areas, so there is hard to find electrical access. So because of the high expenses of electrical infrastructures in rural areas are often more expensive to install than urban areas. So the costing of the management bill is more expensive than the city areas. So as per fact, about 70% of the population lacks access to electricity, and 80% of them live in a rural area at sub-Saharan Africa. So in some country, water heater is necessary because it enables the users to wash dishes, showering, and regulate a room temperature on a cold day. So this is why we need a water heater system in rural areas. So it is also has an impact on washing machines as well as a warm cycle washing helps to maintain the clothes quality. So without water heater system, especially in rural areas, people will have to manually heat up the water, which would be a waste of time. And for this reason, water heaters are essential household appliance that everyone needed, even people living in rural areas. So that is the first problem statement of this project. So the second one is the most of the solar panel, most of the water heater, solar water heater, has a fixed PV panels, photovoltaic panels, which means the angle of the photovoltaic panel is fixed in a fixed position. So there is no movement of the PV panel. So as we know, most of the PV panels for the solar water heater is in a fixed position, which means that the angle of the PV panel is in a fixed position. So there is a problem with that. So the problem is the PV panel does not fully harness the available solar radiance from the sun. Means it will not absorb the fully solar energy from the sun. It will not absorb the fully to the 100%. Means it will not absorb the solar energy 100% from the sun if the PV panel is in a fixed position. So during installation, the direction of the solar panels may not be the optimal angle. So hence the external energy from the sun may not be obtained and wasted. Since in Malaysia, the monthly daily average is a lot around 4,000 watt per meter square. So in the found literature, the efficiency of the solar tracking system could improve the uh, could improve between 20 to 25% for the single axis, while for dual axis maybe it will increase up to 40 to 45 percentage. So means if the solar panel is in a single axis, means it will move in a two direction only, means XY in a XY direction, while the dual axis is it will move in a 360 degrees. So basically we can say that the single axis which is 180-degree angle, 180-degree movement, and then the dual axis is in a 360-degree movement. So another reason why the PV panel should face the sun mostly for while it's working, because it need to be faced near to the sun as possible to capture the solar energy more efficiently. So when the angle at which the sun's ray contact the panel surface, or known as a angle of incidence, so it's the modest, or when the light strikes the panel is close to the perpendicular as possible, photovoltaic create more power. Means when the light strikes more to the surface of the PV panels, so it will get more power. Means the electricity and production will be more. So as a result, the optimal angle for the solar panel is the one that permits solar cells to receive the most direct perpendicular light. So the more the light reach the solar panel, the more the power it can be produced. So that is the problem statement for this project. So after that is objectives. So the objective of this project is there are three objectives. So first of all is to build an efficient water heater system by using solar panel to track the sunlight. Means I want to build a solar water heater system with the tracking system. And then the second objective is to build an efficient solar sun tracking system using a single setup. Means this project, the solar panel will not be in a tilt angle, means in a fixed position. It will be in a single axis setup. Means the PV panel will be moved in a 180 angle, what you call 180 movement. Means the PV panel will be in the XY direction. It will move like a XY direction. And then the third objective of this project is to analyze the performance of sun tracking with the single axis setup and with the conventional setup. Means I want to for this objective, we want to compare the performance of the PV panels for the tracking of the solar energy, which is the better, the conventional way, which is in the fixed position, the tilt angle of the PV panels, or the movement of the PV panels in a single axis movement. So then we move to the scopes of the study. So there are altogether four scopes, which is first one is going to use a 12 volt 3 watt mono crystalline solar panel will be used as a power supply to the project. And then the second one is an Arduino Uno type Atmega 328 will be used as a microcontroller, which it will be used for the use to control the movement of the solar panel in a single axis. So after that, this project is a small prototype and may be developed in the future research. So you can imagine that the project is in a small small prototype. It's not a big project. It's just a small. And another the last scope of the study is a 5-volt servo motor will be used for the single axis sun tracking system. Means we are going to use a servo motor which will be used for moving the PV panels in a single axis with the help of the Arduino Uno. So the next part is methodology. So for methodology, for this project, there is two parts. First one is the software. Second one is the hardware and hardware, which is a prototype. So for the software, going to use coding for the movement of the PV angles in a single axis using microcontroller Uno. And then for the hardware, going to build a boost converter. So let's see the flowchart of this project. So first one, we start with a literature review, and then followed by the parameters calculations. Parameter calculation, for example, for the hardware, which is for the boost converter system. So after that, if it is success, we'll move on to the component selection. If not, back to the literature review. So for this part, parameter calculation components identification, calculation of DC to DC boost converter. So and then if yes means if we move on to the component selection, we will select the components according to the calculations, and then move on to the coding settings for the microcontroller to move the movement of the PV panels, and then move on to the prototype design structures. And then for if yes means if success means we move on to the hardware implementation, and then followed by coding and troubleshoot. And then if success again, we go into more the presentation, and the final is a final report. So for the coding setup, the coding setting using microcontroller Arduino Uno to control the movement of the solar panel, as what I mentioned just now. And then for the hardware implementation, after the success of the coding and the what we call the selection of the components, we are going to perform the troubleshoot and testing the project. So make sure the project of the solar panel is in a single axis modulation and able to detect or absorb the maximum irradiance of the sunlight. So for the PSM one, for the first part, I'm going to do the parameter calculation and component selections. And then for the next part of the PSM, which is the PSM2, I'm going to set up the coding for the movement of the PV panels, and also all the troubleshoots and hardware implementation for the upcoming PSM2. So this is going to this is what is the methodology of this project. So as I mentioned just now, I'm going to build a DC to DC boost converter for this project. So that will be the first part of the PSM, which is the calculation. So I'm going to calculate all the components specifications. So this is basically the what you call general circuit for boost converter. So there we have what you call DC supply, and then followed by the inductor and diode and also capacitor, and then the switch for the converter, and then we have a resistor. So this is basically the general circuit of the DC to DC boost converter. This is I'm going to follow as a reference. So for the inductor selections, I'm going to select the inductor value as a 22 microhenry, and then as per calculation, we getting the duty cycle of this what you call the duty cycle is around 0.2, which is equivalent to 20%. So the switching frequency of the selected switch will be around 16 megahertz, and the inductor will be 22 microhenry. And then this is the calculation. This is the calculation we have done for the duty cycle. The formula is given. V output minus V input divided by V output. So and then the important thing is for inductor, we need to find the what we call the average ripple current as well. So the formula is given as also, and then followed by the capacitor selections. Capacitor selection, for capacitor I have chosen 10 microfarad as a specification for capacitor. So as well, we need to find the ripple current of the capacitor. Ripple voltage of the capacitor. So for the diode, I'm going to use Schottky diode because used in the boost converter, because Schottky diode is preferred because the voltage drop across the diode used under the forward bias is smaller than the voltage drop across a regular silicon diode. For example, yeah, under the regular silicon diode, enhancing efficiency on further. So for the switch, I'm going to use a metal oxide silicon field effect transistor, or known as a MOSFET. So because we're going to use MOSFET because the voltage drops across the MOSFET when turned on is less than other switch, for example bipolar junction transistor. So this increases the MOSFET's efficiency as a switching device. So I'm going to use MOSFET as a switching device for this boost converter circuit. So for the important part is a heating element. We are going to build a solar water heater. So we need to I'm going to build the heating element on. So for the heating element, I'm going to use a nichrome wire because nichrome wire is an alloy formed by combining chromium and nickel. So nichrome is well known for its heat resistance, but it also resists oxidation and corrosion. So nichrome is what we call unquestionably heat and corrosion resistant in water. So we can use in water also. So there is no effect. So nichrome wire is extremely helpful as a heating element and is widely used in commercial and household devices, and such as a dryer, hair dry heating components, heat sealers, and ceramic support in kilns. So the type of the nichrome wire I'm going to utilize in this project is nichrome 80. So nichrome 80 has an excellent form stability, and because of the high adhesion capabilities of its surface oxide. So this alloy has a longer service life than other nichrome wire. So this table 3.1 is a specification of the nichrome 80 wire. So the type of is 80. So the maximum operating temperature is 1180 degrees Celsius, and the resistivity at 20 degrees Celsius is 1.09, and then the melting temperature is 1400 degrees Celsius, and the resistivity of oxidation is high. So the different type of nichrome 80 wire has different specifications. Therefore, a small diameter of nichrome wire should be used because the conductivity of the electricity will be higher and faster. So the ideal nichrome 80 wire for this project it will be cost 20 AWG. Then the average diameter of the wire will be around 0.85 millimeters with length of 100 centimeters. The temperature required is 104.44 degrees Celsius, and the voltage and current required to heat up the wire is around 7 volt, 3 ampere respectively. So next we move on to the preliminary result. So basically just now I showed the calculation for the boost converter, DC to DC boost converter for this project. So this is the parameters and values. So first of all, why I'm going to use boost converter in this system is because the V input, the V supply is 12 volt. So the V input is voltage input is from the solar panel is at 12 volt. So the boost converter is going to boost the 12 volt what you call input to the 15 voltage output. So the V out is going to be is the required voltage output is 15 volt. So that is why we're going to use boost converter for this system. So the selected inductor value is 22 microhenry. The selected capacitor value is 10 microfarad, and then for the switching frequency is 16 megahertz. The duty cycle is 0.2, which is 20%, and the ripple current of the inductor is 6.818 milliampere. This is according to the calculation. Then the inductor current will be 1.875 ampere, and then finally the voltage ripple of the capacitor will be 1.875 millivoltage. So that is basically the parameters after the calculation I've done before this. So followed by this is the components prototype specifications. So after the calculation we are going to according to the flowchart, after the calculation we are going to move on to the component selections. So these are the component sections I'm going to use for this prototype, including the components for the boost converters. So first of all, it's a solar panel. We need to use a solar panel. It's just we need a 1 unit solar panel, which is a 12 volt 5 watt, and then followed by Arduino Uno type Atmega 328. And then the operating voltage is 5 volt, the clock speed, which is the switching frequency is 16 megahertz, and then followed by jumper wires. And then for inductor, then we're going to use an electrolytic capacitor. Sorry, this is a capacitor. So it's on an inductor that is 22 microhenry, and then followed by a breadboard, and then as a base for this circuit, and then followed by a diode, which is going to use Schottky diode. So then followed by switch, we are going to use a MOSFET as a switch for these boost converters, and then going to use a servo motor as well to the movement of the solar panel. And then after that, for this PSM1, I also have done the software simulation for the DC to DC boost converter using what you call one of the simulation software, which is a Proteus 8 Professional. So all the components needed for the boost converter, such as inductor, capacitor, MOSFET, and a switch, as well as switch, resistor, and diode included. And the input of each components are based on the manual calculation as mentioned in chapter 3. So the schematic diagram of the boost converter is stated below, and a DC voltmeter is also connected across the resistor to observe the output voltage, which is we require a higher output voltage than the input voltage, which is a 15 volt. So basically, this is what I've simulated in using Proteus 8. So as we see here, there's an inductor, diode, capacitor, MOSFET switch, MOSFET as a switch, and then followed by the resistor. So this is the voltmeter. So as I simulate in the Proteus in a simulation, I have received the output voltage is around 14.7, and then 14.7, which is more or less is equivalent to 15 volt. So the duty cycle is 0.2, 20%, and then this is the what you call the graph. I've get this in this simulation. So that's it for me for PSM1. Thank you for your attention.